Okay, YouTube, in the last video we saw that we could write the nth root of a number in this rational exponent form, okay? And so rational exponents, or a ratio exponent, is just something like this. If I were to write the square root of 4, we would certainly be able to write this as 4 to the 1/2 power. If we were to write that, for instance, the cube root of 8, we could also write this as 8 to the 1/3 power. What I want you to realize is that this is not the only form that our rational exponents can come in. We say that other rational numbers, such as 3/2 and -1/2, can be used as exponents. So we say two properties of rational exponents are shown here. So let's take a look. We say rational exponents. We say let a be 1 over, let a to the 1 over n be an nth root of a. So in other words, we say the nth root of a can be written as a to the 1 over n power, and we say let m be a positive integer. Then what you see here is this, a to the m over n. So instead of 1 over n, we say that's the same thing as a to the 1 over n times m, or to the mth power. So in other words, we could say that a to the 1 over n to the mth power, we would multiply the exponents here, and what we get is essentially m over 1 times 1 over n, which is the same thing as m over n, which is what we have here. So you can see that a to the m over n really is the nth root of a taken to the mth power. So one thing can be said about this. We can take every rational exponent and rewrite it into radical notation, and we can write it from radical notation into rational exponent notation by making m the numerator of the rational exponent and n the index, the denominator of the rational exponent here. So in general, we say that the nth root of a to the mth power is the same thing as the nth root of a to the mth power is the same thing as a to the m over n, where we're going to write m is the power and n is the root or the index. Okay. So this property of rational exponents basically means that we can write any radical expression as a rational exponent, or vice versa. So now looking at our second property here, it says a to the negative m over n power is the same thing as 1 over a to the positive m over n power. So the negative exponent, we're going to give this a name. It's the move it symbol, is the quote-unquote move it symbol. And the reason why I say this is because whenever we have a negative exponent here, this was over a 1 to begin with. We took the base of the exponent, and it looks like the base moves down to the denominator. But the moment it does this, the exponent changes its sign. So we would say, for instance here, if I had 2 to the negative 1/3 power, that would be the same thing as 1 over, still 2, but to the positive 1/3 power. And all this negative exponent means is we're going to move its base either to the denominator if it's currently in the numerator, or to the numerator if it's currently in the denominator with a negative exponent. And then we could rewrite this as 1 over the cube root of 2. And these would mean the same thing right here, these two expressions. So what we're going to do in this video is we're going to evaluate these expressions, but we're going to do it without using a calculator. So let's take a look at our very first expression here. We say this is 4 to the 5/2 power. I also want to rewrite this in radical notation. Currently, we're saying 4 to the 5th power. We're taking the square root of this. Okay. So when we do this, what I want to kind of emphasize is this. We're actually going to do the 4 to the 1/2 first and then apply the 5. These mean the same thing here. So we're going to do the root first, like all the time. Do the root first. So we say 4 to the 1/2, which is the same thing as the square root of 4. We would get plus or minus 2 to the 5th power. And then what we're going to do is 2 to the 5th power, which we get a negative or a positive thing times itself an odd amount of times would give us a positive or a negative thing. And we get 2 times itself 5 times is 32. So we get plus or minus 32. So now looking at number 6 here, I noticed that we have this 9 to the negative 1/2. That would be the same thing as 1 over 9 to the positive 1/2. And because I have the positive 1/2 power there, I can go ahead and do this root, and I get the square root of 9 being plus or minus 3. So we get plus or minus 1/3 is our root on this problem. Let's take a look at our 81 to the 3/4, which, by the way, I do want to rewrite here. This is also 81 to the 3rd power, the 4th root. But I want to evaluate it in this sense. And again, what we're going to do is the root first. So we say 81 to the 1/4, and we're going to take that to the 3rd power. So 81 to the 1/4, we're saying what is the fourth root of 81, or what could I take times itself 4 times and get 81? So maybe we'll guess and check here. I say 3 to the power of 4 is 81. So this would be a 3 inside of here, plus or minus. We're raising this to the third power. And so a plus or minus to the third power is still plus or minus, and we get 3 to the third is 27. So 27 would be 81 to the 3/4 here, plus or minus. And then last but not least, we have 1 to the 7/8, which I love this one because 1 to the 1/8, or the 8th root of 1, is just 1, and then we're raising that to the 7th. So we really get 1 inside here because the 8th root of 1 is 1, or anyways, the nth root of anything is 1. And then when we raise that to the 7th power, we just get 1. Now the question is, should I have a plus or minus? And yes, actually, because we took the 8th root, which is an even root, we'd better do a plus or minus in front of this here. Cheers.